All right, hello, I'm Mr. Dio. I'm a chemistry teacher at Emerson Junior Senior High School in New Jersey, and I'm really happy to show you another experiment. This video is dedicated to chemistry teachers and to science teachers in general, okay? So today's experiment has to do with synthesis of copper. How do you make copper? Okay, so we're in an area of science called metallurgy, and this is a great topic to have a discussion on in class with your students. So here we go. I do have with me aluminum foil, okay, loosely crumpled. I have copper 2 chloride dihydrate. I have two beakers. One is empty at the moment, and one has some tap water. And I have my thermometer, and I have a scoopula. Okay. So we're going to start off the experiment. I'm going to create 4 systems, and if you know from the next generation science standard, you should be able to define what is a system and what the boundaries of the system is, or the boundaries are. All right, so the first step is to put some copper 2 chloride dihydrate inside of the dry beaker and ask students to study the system, which is the dry copper 2 chloride dihydrate, and write down 3 observations, right? Like, for example, the substance has blue color, you have crystals, etc. Okay? All right, so that's your first step. The second step, you're going to create a new system by asking students to pour your dry copper 2 chloride solution into your beaker of water, unstirred. And in this case, what's going to happen, students should notice that you have a heterogeneous mixture, because at the bottom you have a lot of undissolved solid, and at the top you have lots of water. Okay? So they can write down whether there was an immediate color change, whether it's a homogeneous mixture or heterogeneous mixture, etc. All right, so that's your second system that you're studying. Now your third system that you're studying is a stirred solution, or a stirred mixture. Let's see what happens. So you keep stirring. The color is changing to a different color of blue. That greenish tint has disappeared. Now I'm left with a homogeneous or homogeneous mixture, right? And I can read the temperature, so you can distinguish between a qualitative observation and a quantitative observation. I'll take a quantitative observation over here right now. It's 25 degrees Celsius, right? 25.0 degrees Celsius, right? If you're studying significant figures. All right, so I have my third system. I study it. Students write down 3 more observations. And then finally, I'm going to go to my actual experiment, where I'm going to try to remove copper from that blue solution, right? This is now copper chloride, aqueous copper chloride solution. I'm going to use aluminum, which is higher in the metal activity series. I'll drop the aluminum over here, and I'll use my thermometer to poke it downwards, hold it down, and if you look very carefully, you might not be able to see it. Bubbles are forming, a brown substance is being produced, the temperature is actually going up at the moment. So a chemical reaction is taking place, right? So you notice that a brown substance is produced, and that's your copper, okay? And my temperature is shooting up, and okay, I can hear some sound over here, bubbling taking place. Okay. And my temperature is now rising. It's 4 to 6 degrees, 4 to 7 degrees. When my students do this in class, sometimes they get up to 9 to 2, 9 to 5 degrees. So pretty good experiment. You can add some extra copper 2 chloride dihydrate to your mixture at the moment. All right, I see some white fumes coming up. Probably steam is coming up as the reaction is taking place. Now this is a reaction called a single displacement reaction. I'm now going to put this down. I'm going to walk to the board, and we'll have a little bit of a discussion of what goes on and how you can use modeling to explain what's happening inside of this beaker. Okay, so I'll put this down right now. So I'm going to walk to the board, and we will talk a little bit about what's actually happening inside of the beaker at the subatomic level. All right? So when you look on the board, what you see, I have the aqueous copper 2 chloride solution. This is my blue solution. So I have my blue solution over here. I added the aluminum foil, and I use room temperature and pressure. I get my reddish brown solid being produced. Reddish brown solid. and I got my colorless aqueous aluminum chloride solution. But I also produce heat. So you can have a discussion with your students regarding the production of heat. So this is called an exothermic reaction. Exothermic, T-H-E-R-M-I-C, an exothermic reaction being produced. And then if you want to model this, because this is a single displacement reaction in the form of A plus B, A, B plus C, and then there's a displacement. What I did in class, and which students actually enjoyed, I actually represented the copper using stick figures, right? So that's your copper. I use another stick figure over here. And okay, and I call that chloride. Then what you do next, you represent maybe your aluminum foil this way, right? And now you have your aluminum. And then you can show very clearly your single displacement reaction. So the aluminum will bump the copper away from the chloride, and now you'll be left with the copper, which is this one over here. That's your copper, right? That's your copper. And so that's your copper, and now you're left with aluminum chloride. So that's your aluminum. And the student can have a lot of fun doing this. You can help them to give them a large sheet of paper, and they can actually figure this out for you. Or they can do it in a lab report. All right, and that's your aluminum. And your chloride will be this character. And that's your chloride. Don't forget, your aluminum chloride is AlCl3. So have a discussion with the students regarding how you get that formula, Al3 plus, Cl negative, Cl negative, Cl negative 1, negative 1. So you have 3 positives, 3 negatives. They cancel each other, so you end up with AlCl3. All right, so you're using modeling for the next generation science standards. Students can actually do this on large sheets of paper. You can do it in a lab report. And if you want to know how long this takes me, just developing the lab itself and having a discussion with the class probably takes an entire period. Doing the experiment, writing the report, doing data analysis, thinking about modification to the experiment probably takes another period. So you can budget maybe 2 to 3 periods for this experiment. It's a really lovely experiment. It's a synthesis of copper, and it's really exciting to do. Hopefully you enjoyed this presentation.